Electric energy is an energy source that modern society and mankind can't live without. Most power plants discharge thermal wastewater into rivers or oceans during the process of generating electricity. Power plants use boilers or nuclear reactors to generate steam, which rotate turbines which generate electricity. Water is used to cool the steam after rotating the turbines. Most power plants use water from adjacent oceans or rivers, resulting in large amounts of thermal wastewater being discharged. When discharged, thermal wastewater is generally 10 to 15 degrees Celsius warmer than the surrounding water. This results in the death of local fish, which are sensitive to temperature changes as low as 0.5 degrees Celsius, destructive changes to the marine activity and habitat, and interference with fishing grounds, resulting in less catches for fishermen, causes significant losses. According to the Ministry of Trade, Industry and Energy, the total thermal wastewater discharged by Korea's 6 power companies, 55 billion tons in 2012. This is equivalent to 20 times the reserve capacity of Korea's Soyang River Dam, the largest multifunctional dam in Asia. When the difference between the average temperature of thermal wastewater and the average temperature of the nearby seawater is converted into calories, the heat that can be acquired from 55 billion tons of thermal wastewater equals 900 million gigacalories. By recycling 100% of this heat into heat energy using 국제에너지's ultra heat pump, $60 billion in energy costs can be saved, as well as a 184 million ton reduction in CO2 emissions. The ultra heat pump is a solution optimized for resolving the various issues caused by thermal wastewater and generating enormous amounts of renewable energy by recovering and recycling heat from thermal wastewater. The ultra heat pump, developed by the 국제에너지 R&D team after 10 years of research, utilizes patented technology based on the heat pump logic of pumping heat from a low to a high position to maximize efficiency with minimum power consumption. The ultra heat pump absorbs thermal wastewater heat from power plants to simultaneously generate high-temperature water of 60 to 80 degrees Celsius in the rapid heat exchanger and medium-temperature water of 40 to 50 degrees Celsius in the condenser. If cooling is required, it can provide cold water at 1 to 7 degrees Celsius. Since a sealed heat exchanger is submerged in the drain under the power plant to exchange only heat, it is possible to utilize the heat without polluting the seawater. The ultra heat pump offers enhanced performance compared to conventional heat pumps. One of the biggest differences is the power consumption and efficiency, or COP, coefficient of performance. In case of a 300 RT class pump, the rated power consumption of a conventional heat pump is between 360 to 900 kilowatt. But the ultra heat pump only uses 192 kilowatt when producing hot and cold water simultaneously, and 240 kilowatt when producing hot and cold water separately. While the efficiency of conventional heat pumps is rated at COP 2.5 to 3.5, the ultra heat pump's sum of cooling and heating COP is over 10. Thanks to its outstanding efficiency and capacity to produce hot and cold water simultaneously, the ultra heat pump has been installed in several of Korea's major pharmaceutical companies such as the Green Cross, Huon's Pharmaceuticals, Chungang Vaccine Laboratory, and Yuan Group, earning recognition for its high performance and safety. Heat from the thermal wastewater can be utilized in protected cultivation complexes, heat-intensive manufacturing industries, water parks, and fish farms. Since it is capable of rapidly cooling down to -90 degrees Celsius, it can maximize energy savings by operating refrigerated and frozen warehouses simultaneously. When applied to protected cultivation complexes, it can save on up to 85% of energy costs compared to conventional protected cultivations. It enables temperature and moisture control all year round, making it possible to grow various new agricultural products. It can create the perfect conditions for special purpose crops such as mushrooms, tropical fruits such as bananas and mangoes, and various other crops such as cucumbers, strawberries, tomatoes, and paprika. Furthermore, it allows multiple cropping throughout the year, potentially doubling or even tripling the harvest for improving a farm's income and the local economy. Organic, eco-friendly, and hydroponic cultivations can enhance quality competitiveness of farms. The combination of ultra heat pumps and thermal wastewater is also effective when applied to facilities with high demand for heat energy, such as fish farms near power plants or water parks. By utilizing the thermal wastewater to supply hot and cold water economically in a timely manner, the ultra heat pump makes it possible to create water parks and fish farms which operate year-round. Lastly, it's also suitable for manufacturing industries which use large amounts of heat energy while adhering to indoor temperature and humidity control requirements such as pharmaceutical, biotech, semiconductor, food, confectionery, and meat processing industries. Because of the nearly infinite amounts of heat energy which can be supplied at very low costs, building a large heat-intensive industrial complex near a power plant can significantly increase the competitiveness of manufacturing industries. It also allows flexible compliance to low carbon economy, which has become a key issue following the UNFCCC. As you can see, deploying 국제에너지's ultra heat pump in thermal wastewater recovery projects can protect the marine ecosystem, lead to the development of a new agricultural tourism city, and create a large number of jobs. It is also the most effective measure in reducing greenhouse gas emissions, with the aim of providing a true solution to the issues posed by power plant thermal wastewater and becoming a global leader in the thermal wastewater recycling industry. 국제에너지 invites you to take part in this new renewable energy development project. Thank you.